Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a fascinating paper that addresses one of the biggest hurdles in robotics: sight. Most robots today are essentially blind to anything that isn't directly in front of their fixed cameras. If an object is hidden behind a box or tucked inside a cabinet, a standard robot simply cannot find it. The researchers have introduced a framework called SaPaVe, which stands for Semantic Active Perception and Active View Execution. This system gives robots the ability to strategically adjust their viewpoints to acquire relevant information in cluttered scenes. Imagine a robot rotating its head to peek inside a cabinet to find a bowl, rather than just staring at the closed door. This mimics how humans naturally move their heads and eyes to understand the world around them. To make this work, the team developed a clever architecture that separates the looking actions from the moving actions. By decoupling the camera control from the hand manipulation, the robot can learn each skill more efficiently. A specialized universal spatial encoder is used to help the robot understand 3D geometry and depth. This allows the machine to maintain its accuracy even when its head is moving rapidly. Teaching a robot where to look requires an enormous amount of data. The researchers created a dataset called Active ViewPose 200K, containing 200,000 pairs of images and camera movements. This dataset helps the robot learn the relationship between a verbal instruction and the physical movement needed to see the target. For example, it learns that look under the table requires a specific downward tilt and rotation. To test these skills, they also built a comprehensive simulation benchmark called Active ManipBench. This virtual world features 12 distinct tasks, 100 different objects, and 20 diverse indoor scenes. It provides a rigorous environment to see if the robot can successfully handle occlusions and tricky angles. The results showed that SaPaVe outperformed previous models by a significant margin, achieving a 75.2% success rate. The tasks themselves range from simple pick-and-place movements to complex, long-horizon sequences. In some scenarios, the robot must open a drawer, find an object inside, and then place it on a counter. It even includes tasks involving dynamic fluids, like picking up a bottle and pouring its contents accurately. These simulations ensure the robot can handle the physical complexities of a real-world home environment. Beyond simulation, the researchers proved the system works on a real Unitree G1 humanoid robot. They demonstrated that the robot can even recover from unexpected disturbances during a task. If a person moves an object while the robot is reaching for it, the machine can reinitiate its search and reacquire the target. This closed-loop perception makes the robot much more resilient and reliable in changing conditions. Let's recap the most important points from this research. SaPaVe allows robots to purposefully move their cameras to solve tasks, a skill known as active perception. By training the robot in 2 stages, first to look, then to act, it becomes much more capable in messy, real-world environments. This breakthrough could lead to a future where robots are no longer confined to static workstations. Looking forward, the researchers want to extend this system to mobile bases. This means robots wouldn't just move their heads, they would walk to different rooms to find objects based on your commands. We are moving toward truly general-purpose assistants that can navigate our homes and interact with our world just like we do. Thanks for watching Summarize Science, and we will see you in the next episode.